Okay, what I want to do first off today is just give you a brief overview of the t-test and the matched pairs t-test. Just for review, for last week we did the z-test, and the z-test is applicable when you have a population standard deviation sigma. So if you have sigma, the population standard deviation, then you will use the z-test. And if you'll go back and look at the problems that were assigned for this week, they all have a population standard deviation. If you have S, the sample standard deviation, either because you have numbers and you had to calculate the standard deviation yourself from sample data, or in a problem if it gives you the sample standard deviation instead of the population standard deviation, then you will use the t-test. And then there's a t-table that goes along with that. And one thing that I'll go ahead and tell you about, right here, the t-test. One thing I'll tell you about the t-table is that it's really a set of tables, and we're just going to have a row at a time on it. And you have to be able to use degrees of freedom, which is n minus 1 for the one sample t-test, which is what we'll do now. Here is a t-table, and let's say that we had a problem where we had n was 16. I'm going to be able to do that. Okay, so let's just say n was equal to 16, and we had alpha of 0.5 and a one-tailed test. So I'm coming up here, one-tailed test, alpha 0.5, and if n was 16, we go down to 15 degrees of freedom, or 1.753. So what these numbers are is just a list of critical values, just like last week we had for a one-tailed test 0.5, we had 1.645 for the z-test, and so on. So wherever we were using those numbers from the table of common z-values that I gave you last week, we'll be using these numbers here. In fact, if I go down to the bottom here, what you can see is the last row of the t-table. My t-table goes up to 100, or degrees of freedom equal to 100. The last row, where n is infinity, you have confidence level 90%, 1.645, confidence level 95, 1.96, and hopefully those numbers sound familiar to you. They're the same numbers we used last week. But anyway, just when you're doing when you have a sample standard deviation, use the t-table and correct for degrees of freedom. That really, in a nutshell, are the only differences between the z-test and the t-test and the z-test problems which we were working last week. Okay, so we'll be doing the t-test. The other test we're going to do is called the matched pairs t-test. The matched pairs t-test. And the hallmark of the matched pairs t-test, also just called the paired t-test, also called the dependent samples t-test. I'll refer to it as either the paired t-test or the matched pairs t-test. This is basically the big example of the paired t-test. It's not the only example of the paired t-test. Is a pre-test post-test. So if we have pre-test scores of 3, 8, 9, and so on, and we have post-test scores of 5, 10, 14, what we'll do is we'll let X equal difference and so, for example, in this one, if we do post-test minus pre-test, x will be 2, that's just 5 minus 3, 2, that's 10 minus 8, and 5, 14 minus 9. And then what we'll do is compute the mean and the sample standard deviation of these numbers and do a t-test. So that's really the overview of the material for this week. We're doing the tutorial problems just to kind of work through details on it. Well, if you have population standard deviation, use the z-test. There are no degrees of freedom to correct for, so that's just what we've already done. T-test, we have a sample standard deviation. That means we use the t-test. We correct for degrees of freedom. The matched pairs t-test is just another t-test. It's just that it starts out with, instead of just giving you x values or sample means and so on, it gives you pre-test and post-test, or before and after scores. They can be matched in other things too. It could be like husband and wife and their attitudes towards something, and you're looking at the differences there. But the most common one is by far is the pre-test, post-test, or before and after kind of thing. So to do the matched pairs t-test, let x equal the difference, then do a t-test. In this case, you start having the x values, so you actually have to compute the mean and the sample standard deviation yourself. Of course, that could also have been true in the t-test. I might give you a problem where I give you the sample standard deviation, or I could give you a problem with data in which you calculate the mean and the standard deviation yourself.